Hello and welcome for a new video about Stellar. Today we're going to talk about pre-signed transactions. So first of all, I want to assess the fact that in the Stellar world there might be a bit of confusion between what are pre-signed transactions and what are pre-authorized transactions. Pre-signed transactions are transactions that are signed but not submitted to the network. Pre-authorized transactions are a different matter. They are related to a compliance server, and this is for probably another video. So a signed or pre-signed transaction in Stellar is simply just like a check. The difference might be that you can add some more constraints on that check, and an important one is that you can actually create some sort of time bounds. So say my check will be, or my transaction will be signed, sure, but it's going to be only valid for a given amount of time or from a given date. So that's what you can do with that. So we're going to do an example today with the Stellar SDK, and I'm going to quickly present that, and then we're going to code that. So first of all, we will need two accounts, Alice and Bob. Alice wants to send Bob money for some sort of a job. Never mind, it's a very simple example. So Alice will create an escrow account, and at the same time, as Alice created the escrow account, she still owns the private key of the escrow account. So she's going to create a transaction from the escrow account to Bob. So for now, the escrow has no kind of value per se, but there's a transaction that has been created by Alice from the escrow to Bob after a given amount of time, for example. This transaction can be saved as a file or any kind of sort of format. And Alice can send that to Bob and say, okay, Bob, this is the transaction I have for you. It's going to be valid in, say, 3 months. That's yours. And that's it. That's all it is. The next thing we'll do, for example, is that we are going to make a transaction from Alice's account to its escrow account to get a bit of fun inside the escrow. And the next step is that after a certain amount of time, Bob will just submit this transaction and he should receive the amount that was inside this check, kind of. After that, this transaction won't be valid anymore. And in the end, we'll also merge the escrow account back to Alice's account, because a Stellar account needs a minimum balance to have some sort of a life or to exist on the ledger. But this kind of value is lost if we don't do that. So one thing you can do is to, at the same time you do this transaction to send the money, the payment to Bob, you can also say that the escrow account will merge back to Alice's account. Okay, that's what we're going to do today. And now I'm going to switch to the code. So we already have a few files in this repository. I also have a lib.js file that will be used only to save JSON files and the package.json. I'm going to install the npm dependencies. We also have an account.json that is already prepared with Alice and Bob's public-private key ready to be set. And that's the first thing we're going to do. We're going to generate those pairs. So Alice first, and we're going to fund Alice's account. Now let's verify that it has worked. Okay, so we got 10,000 lumens. I'm going to do the same for Bob. We don't need Bob's private key actually. And same thing, it's going to be a funded account as well. So let's verify. Okay. Now it's done. So 10,000 lumens as well for Bob. Okay, just a few files to ignore the node modules and the account.json, because we don't want to have this on the repository. Now regarding Alice, I already have a file, which is the create escrow.js. You will see that there's a base reserve and number of entries constants. We'll speak a bit about that later on. Now the first thing would be to create the escrow account key pair, and Stellar has a method for that on the SDK, the key pair random. So this account will be only used just for maintaining a few of the balance we want to send to Bob. So it's not really important for us. We don't want to keep this forever. So public key and private key in an escrow object. We're going to mimic and have a similar data structure as the JSON file for the accounts, because it's an account. And we're going to display this account as well as saving the data of this escrow account, the key pair. Okay, so let's verify that it works. We've got the new file created, and we're going to also ignore this file. We want to maintain it in the repository. Now we want to fund and create these accounts, so Alice will do that. So we're going to use Alice's account to create and fund a new account. What it means is that Alice and Alice's balance will be used to add the minimum balance needed for an account to exist on the Stellar network. So transaction options, standard one, and let's create our create escrow transaction. So the operation will be an account creation. And the destination will be our new public for this escrow account. As for the starting balance, so there's some sort of a formula for that. I'm also using the big number library. It's a bit overkill in this case, but it can be useful and also used under the hood by the Stellar SDK. So this formula that you can see, 2 plus number of entries multiplied by the base reserve, is coming from the documentation of Stellar. And this is corresponding to the minimum amount of Stellar elements you need for an account to exist and to be maintained or persisted on the network. I will link in the description below to this page. Now Alice will sign this transaction. And we are going to submit this transaction to the network. Okay, let's try. We're going to see if the balance is fine, if this account exists. And it's alright, 1.5 elements. This account has been created. This is the escrow account. The next step will be to create the pre-signed payment to Bob. So it's going to be a transaction that goes from the escrow account to Bob. Bear with me for now, the escrow has just 1.5 XML. So the first thing we want to create a now, which is this timestamp of the date at the moment we create the pre-signed transaction, and we are going to use this point in time afterwards. We're going to import the escrow account's public and private keys as well, because we've just created them. And transaction options. So the beginning is standard with the fee, and the passphrase will be always the same for the testnet. The difference here is that we are going to add time bounds. So remember that we wanted this transaction to be valid only after a certain amount of time. So say that we want it to valid, we want this transaction to be valid 30 seconds after it's been created, for the sake of this example. That's what we do with the min time attributes. The max time will be 0, because we don't care when it happens actually in the future. It can happen in 1 year, it's going to be still valid. We are worried with this. Let's create our payment transaction now. So it's going to be a payment of 100 lumens, for example, and it's going to be Stellar lumens, the native asset. And the destination will be Bob, obviously. So we're going to sign this payment with the escrow private key, which Alice, the Alice entity, has created. Now we said that we wanted also to merge the escrow account once this transaction is executed. So it's going to be part of the same batch if you want. And we're going to say that, okay, now I want to merge the escrow account into Alice's account at the same time. So payment and merge at the same time. So this account won't be submitted. We're going to save it in a format known as XDR. So there's a way with the SDK to generate this format. XDR is for external data representation, and it's a format that is widely used with Stellar transactions and other type of data structures. We're going to make this a bit more human readable with an object which we can call payment receipt. With the XDR of the transaction, the source of the transaction, which will be the public key of the escrow accounts, and the amounts. So let's display that on the console. And we are going to also save this file. It's like sending it to Bob if you want. Let's try if it works. Oh, small error. Small syntax error. Let's try again. Okay, we've got it. So as you can see, the XDR transaction can be parsed in the laboratory of Stellar Laboratory, and we can see all the details of what we see. We also see that the signature is valid, so it's already a signed transaction. Next step will be to fund the escrow. For now, the escrow account is still with 1.5 lumens. If you want to pay 100 lumens to Bob, it needs to be funded, but we don't have to fund it directly. We could say, oh, I'm going to wait to have this money or something. Or we could say that I'm going to fund this account once, for example, Bob has finished his job. So there's no obligation to create a transaction with the amount already on the account. Okay, so it's going to be a standard transaction. And we're going to have Alice to pay the escrow with 100 lumens. So Alice will sign this transaction. And we're going to submit that to the network. Let's try if it works. Okay, so now the balance on the escrow is fine, 101.5. The next step will be for Bob to submit this pre-signed transaction. So I've already prepared a file as well, and now we're going to just extract the XDR file, the XDR formats, and recreate the transaction with the SDK. So Stellar has all the tools you need for that, and you can recreate the transaction from the XDR version of it. Now I'm going to cache the error just to display what happens if, for example, we submit the transaction too soon, too early. Let's try that. Okay, it's been more than 30 seconds, so we can see that the escrow account doesn't exist anymore now, which means that probably Bob has received the balance. And yeah, it's the case. 100 more lumens. Now we will try from scratch with new accounts for Alice and Bob. So first, Alice will create the escrow account. Okay, check. Then Alice will create the pre-signed transaction. Okay, we can see that here. And now Alice will fund the escrow, and we can check that the escrow has now the right balance. So let's quickly submit Bob, and as you can see, a transaction via Bob. You can see the transaction hasn't worked. It's written it's too early. We've been under 30 seconds. So we'll try in a few seconds. Now it seems to have worked. Let's check the balance. As you can see, the escrow account doesn't exist anymore. Let's see if Bob has received the lumens, and it does. So as you can see, it worked. So Bob has been able to submit the transaction on its own. Voila. I hope you enjoyed this video. There are some limitations we haven't discussed about Stellar and other considerations regarding the sequence number, for example, but we'll probably discuss that in another video. Thank you for watching, and you will find all the links in the description below, as well as the source of this repository we used. Thank you.